Okay, so we're going to be looking at Kubernetes cluster IP as a service here. This is following along with a blog post I put out on vrelevant.net, and you can find a link to that in the information below the video here. So I'm starting off, I'm just taking a look at kubectl get pods. I've got none now, so I'll go ahead and create a deployment. I'm going to create a deployment based on Nginx image, and I'll be using the web service only, just to use the curl command and show kind of how we interact with the IP addresses. So we've got one pod running. I'm going to go ahead and scale this to 3. And we should see it scaling out now. We've got 2 more container creating pods, and we're up and running. So now we can take a look at the IP addresses that were assigned to those pods. You can see we have 172.16.0.6, 172.16.0.7, and 172.16.0.5. And those IPs came from our pod IP range. Because these are cluster IPs, they're not exposed, so I'll go to a worker node now, and I'll go ahead and use the curl command on one of the pod IP addresses. So .6, we can see Nginx responding with the HTML. And we can go ahead and check .7 and .5 as well. .7 responds and .5 responds as well. So we have 3 pods running in our deployment replica set, all with unique IP address in the pod IP pool. They are responding in cluster to our curl request for the service that's running on them at port 80. But as we talked about in the blog post, you do not want to target a pod IP address. A pod is meant to be ephemeral, to be potentially short-lived, and if and when it's recreated, we'll receive a new IP address. So let's take a look at that now. I'll go ahead and kill a pod, and then we'll see it recreated based on the declarative state that was made for it. And then we'll go ahead and take a look at creating a service to front end these 3 pods as endpoints. I'll go ahead and delete the first pod in our list here, which is running at 172.16.0.6. And we see it's deleted. If we do a get pods again, we'll see that Kubernetes has recreated the pod, but now we have a new address, which is 172.16.0.2. So if we had continued to address .6, we would have a problem. We can see that with the curl command here. If we had another pod or service that was addressing that pod by its IP address, we would no longer receive a response from it. That IP address no longer exists in the cluster. It's now at 172.16.0.2, as we can see here. So the way to resolve that, or to avoid that problem, is to create a service address where we're exposing the deployment or the replica set with a front-end IP address that is more stable, that is persistent across pod restarts. And that is what we call a service address. And in this case, ClusterIP being the service type that we're going to look at. So what we'll do next is expose that deployment with those 3 replicated pods running behind it as what we call endpoints. So we'll create a service IP address, which will then be the front end, a in-cluster or a cluster load balancer for those back-end pods. And what Kubernetes will do is manage the state of that, so that if a pod is recreated and receives a new IP address, that front-end IP address, which is load balancing, will know that, be updated, and continue to serve that pod as a service. So I'll start off by exposing the deployment. This will create a service. I'm not going to specify service type, which will default to ClusterIP. And we're doing our Nginx dev deployment. And I'm going to say port 80 and target port 80, which is saying that if I go to the service IP address, that we will be targeting 80 on service IP address, and it will serve and load balance back to the endpoints at their port 80. You can see the service IP address is type ClusterIP and that it is 10.100.200.183. This is from our service IP CIDR for the cluster. It's the third CIDR that we didn't talk about in the first two posts, but did in this previous post. So there's node IPs, pod IPs, and now cluster service IPs. This is the IP that will front end our deployment endpoints, the 3 pods running on their IPs that could change. This IP will not change. And if we address this IP, it takes care of any issues with pods being recreated and having IPs reassigned. Okay, so if we describe this service now, we should see the endpoints or our pod IP addresses that it's front-ending or load balancing to. And then we'll go ahead and take a look at pods wide and just make sure those IPs are still the same. And if a pod IP changes within our deployment or replica set, it will be reflected in the load balancing of our service. And now we should be able to curl our service by its IP address, and we are getting load balance back to our endpoints for the Nginx service. So that's it. That's the service. The cluster IP service in another blog post I'll review and go over some of the other services that are available, node port, and then we'll see how a load balancer would use a node port. But that's it for now.